NASA's SnowEx is a multi-year field campaign to test a number of different remote sensing technologies that might get launched from space or in preparation for some planned satellites. In past years, we've had a lot of people from all over the place, even internationally, come together to collect observations and conduct a several week-long campaign. This year, we really had to change the design of that, and now we're focusing a lot more on local teams. So we have local research groups who have maybe been using a study area for a number of years, continuing to collect observations and following the SnowEx protocol. So at all these sites, they're collecting the same observations on the ground while the different planes fly overhead. One of our sites is in Idaho, is being led by Boise State University, and a number of graduate students are going out on a weekly basis to collect observations.
I think one of the things that makes Boise State really unique in terms of snow research, one of the big ones is how accessible the mountains are. We're only 15 miles from the campus, and so we can get folks into the winter environment relatively easily. Snow impacts both Boise and Idaho because in this part of the world, our water supply comes primarily from the seasonal snow cover. About 70% of our water each year comes from the snow that falls in the mountains. And that's important both for water resources, for recreation. A lot of people use our river systems, so it's a big part of the economy, for agriculture, and then also for hydropower. And then predicting the amount of snow that we have in the mountains is important for flood forecasting as well.
We are digging a snow pit, and we dig one in the open and one in the forest. And within the snow pit, we measure the different layers of the snowpack. And then in each layer, we look at the snow crystal types, as well as the size of the snow crystals. And then we measure the density of the snow and measure the liquid water content. So we're looking at how much water is in the snowpack.
So a LiDAR system measures the height of the snow, and this specific system we're working with Silverhawk Aviation out of Caldwell, and it's allowing us to very quickly integrate that instrument and then fly on about 24 hours notice. What we're really finding is that the solution to the snow problem is going to require field measurements like we're doing today, remote sensing like the helicopter that flew over today and the satellites that are timed to overpass our site, and combining the models, the remote sensing, and the ground measurements. All three of those pieces are very critical. Snow is a relatively new science, and so a lot of the problems that we tackle are questions that a lot of people haven't actually looked at before. And what that means for, I think, students is that it's much easier to make an impact than in some of these other fields that have been studied for hundreds and hundreds of years.
NASA's interest in studying snow, there are a number of different objectives. So, from the water resources side, snow is incredibly important. And in the western United States, a lot of the water resources come from snow. In other areas, it's hydropower. It provides some infiltration into the soil, so for agriculture. It also feeds into some climate change questions, how the snowpack is changing, how does that influence the energy balance of the Earth.